Is it recording? There you go. All right, so 11.2 is specific to the arithmetic sequences. And there are, like in 11.1, there were arithmetic sequences, there were geometric sequences. We talked about recursive sequences, all sorts of different things in 11.1. 11.2 only focuses on arithmetic sequences. So what's an arithmetic sequence? See if we can remember how to find the nth term. I'll give you a minute to figure out the nth term for that one. Alright, so arithmetic sequences have something called a common difference. Common difference is what it goes up or down every time. So what is my common difference in this problem? -3, very good. So it's going down 3 every time. That if it goes up or down the same amount every time, that's called an arithmetic sequence. So common difference is -3. So that's kind of our slope if you think of it as a line, so -3n. And then how do I go from -3 to 8? What do I have to do? Add 11, very good. So that's your first term, second term, third term, fourth term. We could plug in 4 for n, so -3 times 4 is -12, plus 11 gives me -1. So that's my nth term right here. I'll do one. How many got that? Raise your hand. Okay, so remember that. That's how you'll always do. If you have a list of an arithmetic sequence, you can do it that way. I think we're getting that. What if I wanted to find the 100th term? Very good. You put 100 in for n. It would be a sub 100 equals -3 times 100 plus 11. So -300 plus 11, what's that? -289. Okay. So if you can figure out the nth term, then you can find any term by plugging it in. If we went back and we know that this is going down 3 every time, if I wanted to write that recursively, you would say the next term is equal to the current term minus 3. That would be recursively defined. To get the next one, you just take the current term and subtract 3. Or you could say, to get the current term, you take the previous term and subtract 3. So that's recursively defined. That works great once you see what the pattern is, but if you're asked to find the 100th term, if you just know the recursive, then you just have to keep subtracting 3 100 times to get to your term. So it's better to find the nth term explicitly, and then you can plug it in. Alright, so let's say you have, I'm going to make one up here. Let's say we have a sub 2 equals 17 and a sub 5 equals 26. Now I want to find the nth term. Okay, different type of problem. It's still an arithmetic. It's an arithmetic sequence, and we want to find the nth term. Okay, so with enough time and enough thought, you could probably, well, I have confidence that everyone in the room here could eventually figure out what the common difference is. Okay, because we have our second term is 17. Is 26. Can anybody figure out what the common difference is? Well, we know it's going up. How much is going up every time? Alright, so wild flash 3 and 3 is correct, yeah. So if I if I add 3, I get 26. It works out. So I could work my way backwards. So the first term would be 14. So the nth term, we could say 3n. How do I get from 3 to 14? You'd have to add 11. Okay, so that's kind of how you could do it. It is not how I would recommend it, because what if I had like the 30th term in the second term and you're going up by 1.7? That would be kind of a disaster. So here's how I would recommend doing it. And I don't know that the book would do it this way. So if we have two terms, we know that the second term is 17, the fifth term is 26. I would treat this as a set of two ordered pairs, 2, 17 and 5, 26. Okay, remember arithmetic sequences. If I plot all the points in arithmetic sequence, they form a line. That's not a very straight line, but if I did it correctly, they all form. You don't connect them because you can't have a 1.1th term. They're discretely graphed like this, but if you wanted to connect them, it would be in a line. Okay, so this is basically two ordered pairs forming a line. Well, you need to know the slope and the y-intercept. Remember how to find the slope of 2 points? I hope so. 26 minus 17 over 5 minus 2 gives me 9 over 3, which is 3. This is the slope formula. That's what I just did. Okay, so we know our slope is 3. Well, we already know that. And we could also find the y-intercept by doing mx plus b. So my slope is 3. I need one of the two ordered pairs. I'll choose 2, 17. So 2, 17. So b, if I subtract 6, is 11. So notice that's my b right there. 3n plus 11. Don't write 3x plus 11. We're in n mode. We're in sequences. But you get the slope and the y-intercept, and that will help you form the nth term of the sequence. All right, I'll have you try one here. I gotta make one up. Let's go 3, 2 and 10, negative 12. See if you can find the nth term. Oh, I'm sorry. I should have written a sub 3 equals 2 and a sub 10 equals negative 12. All right, looks like most pencils have stopped moving. So again, this is what you're going to be given. Two terms. You can turn them into order pairs, 3, 2, 10, negative 12. So now we can find the slope. Negative 12 minus 2 over 10 minus 3 gives me negative 14 over 7. So our slope is 2, negative 2. So y equals mx plus b. My slope is negative 2. My x, I'll choose 3, 2. So it'll be 3, 2. So if I add 6, I get 8. So I have my y-intercept, and my slope. So my nth term would be negative 2n plus 8. We got that correct. We all liked algebra, didn't we? Really? All right, most of you agreed with me, and Claire is thinking no. Pre-calc's way better. Wait, don't answer that one or respond. Okay, so what if I have 2 plus 6 plus 10 plus 14 plus 18? We'll call that good. If you wanted to find the sum of this arithmetic finite sequence, how do I know it's finite? Because it ends. Yes, it doesn't go forever. If it went forever, what would our answer be? What would those all add up to be? A really big number, infinity, right? Yeah. What if you're subtracting 4 every time? Negative infinity. That's kind of boring. So the only way you'd get an arithmetic, well, you'd either get positive infinity or negative infinity. So this is a finite. We could literally just add them up. Did anyone do that already? Is it 50? We didn't do it. All right, 8, 18, 32, I get 50. Okay, so that's great as long as you only have 5 terms. If you had 100 terms, that would be pretty stay focused. There we go. Okay, so here's the formula. It's n over 2 times a sub 1 plus a sub n. This is the sum of a finite arithmetic sequence. And n is the number of terms. A sub 1 is the first term, and a sub n is the last. So how many terms do I have in this one? 5 terms. Okay, so my n is 5. So I have 5 over 2 times my first one, which is 2, plus my last one, which is 18. So 5 over 2 times 20. 20 over 2 is 10 times 5 is 50. So that's using the formula, we get a sum of 50. On your assessment, I would expect you to use the formula. I will intentionally have lots and lots of terms where you can't just grab your fingers and go 1, 2, 3, 4 and count them up. I'm going to want you to use the formula. Maybe I'll put 1,000 terms on there. Okay, so try this. Find the sum. Good enough, I'm out of paper. Okay, so try to use the formula for this. Come on, camera. There it is. All right, so n is 1, 2, 3, 4, 5, 6, 7. So 7 over 2 times the first one plus the last one. 26 divided by 2 is 13 times 7 is 91. Is that right? Okay. All right, another example. Find the sum of the first 100 terms. So what do we have to do in order to find, I didn't see anyone doing 8 on their calculus, 5 plus 8 plus 11 plus 14 plus 17. What's the first thing you have to do? Yeah, you need to find the nth term. The nth term will help us find the 100th term, and then you can use the formula. So I'll give you one more minute here. Who's got an nth term for me? Ben's got it.
3n plus 2.
3n plus 2, very good. 3n plus 2, I would agree with that. Okay, so now we can find the 100th, so it'd be 3 times 100 plus 2, so we have 302 for the 100th term. All right, well, how many terms? Well, that's pretty easy. There's 100 of them. So it's 100, that's our n, over 2, times our first one, plus our last one. So 307 times 100, so that's 307 with a couple zeros divided. What's that? 15,350. There's the sum of our first 100 terms. Questions on any of this stuff? I think you'll like it. Just that you can use just formulas. They're all either going up or down the same amount. They're all the same type of a sequence. You can use y equals mx plus b stuff just for these arithmetic sequence ones. Once we get into geometric sequences, we'll have to use different techniques.